Hi, welcome back. I am Pushkar. So in all our previous videos, we went through the concepts around blockchain, smart contract, different fields of Web3, different development platforms around Web3. And then we also had a dedicated series around Solidity and understanding Solidity and its concepts and how similar it is to any other object-oriented programming. So what we'll do is from this video, we'll get started with actually writing our own smart contract and then testing the smart contract. Since you know that smart contract, they are basically immutable on the blockchain, so the test cases become very important. And then we'll also go ahead and deploy it, and in the later half we'll also be using the same project in order to integrate it to the web front end maybe. And yeah, I mean we can basically create our first decentralized application itself. Also, I mean, some of you might have watched all those concepts and are familiar with it. But even if you are not familiar with all of those and never heard of Solidity and smart contract before, the video basically aims to inspire you to dig deeper into the world of smart contracts and maybe write your own smart contract. So let's get started. So the first thing that we will be doing is basically setting up the project, and now what we'll do is we'll basically be using the npm projects. I have already created a empty first smart contract project, right? And what you would need is I am using this the VS Code, and I will be using Hardhat in order to configure all the development environment locally. We have already gone through the remix ID, so go ahead and check that out. So what we'll do is we'll basically be needing few dependencies. So in dev dependencies, we'll need to have Node.js and npm installed locally. So if you don't have Node.js, or if you have or not, and if you want to confirm that, so maybe you can just do node -version and can quickly check it. So I already have Node installed, and then you can also check the npm, right? So npm again same -version. And I have both of it installed. If you don't have them installed, go ahead to the website and get that installed straight away, right? So what we'll do is we'll first initialize an empty npm project, right? So you just have to create a package.json. We'll start configuring it, and then we'll create our first project structure, right? So the first thing will be like npm, and you just write init -y, and here you go. Now if you see here, this is my package.json that has been created, and what we'll do is we'll basically build on top of it, and then we will create our own own project. So what I'm going to do is I will be using Hardhat for local Solidity development environment, but you can use any other development environment as well, like Truffle, and you can go ahead and check that out. I find Hardhat very easy, so I will be taking that reference. Maybe we can discuss about Truffle in later videos as well. So what you have to do is, and you just have to type, say, npx Hardhat, right? So it will be Hardhat, right? And then the magic happens, right? So now the Hardhat basically comes up with the npm package and various tools that enables us to develop smoothly. It also allows us to deploy our contract, run test cases, and even better is that it allows us to debug Solidity code without dealing with the live environment. So I have already ran this npm Hardhat. Now it is asking me whether to install the following packages. So I will just say yes to proceed, right? And there you go. It is basically going in and installing all the dependencies for us. Now we'll wait for the dependencies to complete. So just to give you more understanding, that Hardhat init command, it creates like config file for us. It also updates the package.json, and along with that it also creates a base folder for our Solidity project, right? So suppose in case if the init command does not update, then we have an option of basically writing down custom npm command like npm install -save dev and hard hat. You can get all of this on their link, so we'll put that the hard hat link into description as well. Okay, so it created everything, and yeah, I think the sample project is ready. So just a second, let me get this. Do you want to add a git ignore? Yes, I will do that. And do you want to install this project dependencies with npm? Yes, we'll do that, and we'll discuss about all those dev dependencies in detail. But before we get started with the dev dependencies, so you see, once we did npx hard hat, it has created a folder structure for us. So now there are three important things that we have to keep in mind. One is the contract. The another one is the script and the test, right? So the contract is where our Solidity code is basically going to be. So this is where we'll be writing our smart contract, right? Then comes the script. Now script is basically, it is like a task runner with a development environment in it. And then comes the test. Now the test is basically with npx, the test comes up with a test framework, right? That allows us to test the contract locally by creating like some type of a more natural language for test cases, right? So yeah, I mean, if you see here, our project is ready, right? So you can just go ahead and can check this out. So one important thing that I explained and I discussed while the npm was being installed was basically the hard hat config. Now let's go and check what exactly the hard hat config file is. Now this hard hat config basically configures the plugin to be used, right? So the plugin to be used it needs to be in the required params, right? So here if you see the required, we need hard hat waffle, and similarly there are other dev dependencies as well. The second one is basically the script. So right now we just have a sample script. So in our project we will be writing a contract, also will be testing it and then deploy the same to the local testnet as well. So what we'll do is we'll first go ahead and we'll update our package.json, right? So let me go to the package.json. So right now this is how the package.json looks like. As far as say these dev dependencies are concerned, so we'll discuss onto that what these dev dependencies are. But quickly what I will do is I will write down few scripts here, right? So the first script will basically is going to be a build script, right? So build script will basically allow us to compile the Solidity code that will add. So it will be like a hard hat compile. And then similarly we'll have something called the test waffle. Now test waffle is where we'll be testing out our Solidity code, right? So test waffle, and then what we'll do is this will basically be hard hat test. Okay, and the third script that we are going to write is basically the test, where it is going to generate a coverage report for us as well. So it will just be test. Okay, so we already have a test key, so we don't need this test, and we will have this hard hat coverage here, right? So let me quickly have this. Yeah, so we are all set now, right? So just to explain again, the build, it's something, it tells the hard hat to take our Solidity Solidity files from the contract and then run them through the Solidity compiler. As far as the test waffle is concerned, it not only invokes waffle, but additionally it is going to generate a coverage report for us. And the third one is the test. Basically it invokes waffle and additionally generates a coverage report for us, right? So now this is how our package.json is going to look like. Now what I will do is we'll go through the contract file and we'll start writing our first smart contract, right? So so this is where we'll write our smart contract. What I will do is I will go through step by step, because this video is basically dedicated for those who even don't have any idea about Solidity programming. So I will basically be going through step by step all the lines of code that I will be writing here, and then we will I think then we'll compile it and then it will be easier for understanding. So now that our project setup is done, all the dev dependencies are installed, we have updated the script as well. So let's go ahead and write down our first contract. So if you see here, by default hard hat has basically given us a contract name as greeter.solidity, and corresponding to this contract itself, they have also included a sample script and a sample test file as well. However, I think anyone who is coming, irrespective of the programming language, they would understand the counter app anyway. So what we'll do is, instead of greeter.solidity, we'll create our own counter smart contract. So let me get rid of this. So I will delete this, and I will be creating another contract file called as counter.solidity. So it will be like counter.swl, right? Okay, so let's get started and let's write our first smart contract, right? So now a typical Solidity file usually starts with a proper licensing, right? So now why licensing is important is because license build trust with the community, and hence it is always recommended to add a license to our contracts, right? Now the second file, which is the pragma solidity this. So if you see our previous versions where we have explained the smart contract in the Solidity series, you will understand what pragma means. But just to reiterate, now pragma is like a keyword, it's like a directive which states that this specific source file, which is the counter.solidity in our case, needs Solidity compiler version of whatever the version that we have given. So in this case I have given the version number 0.8.0 and more, and does not work with the compiler version below that. So this is something which is only local to this particular file itself. So suppose if we import a file that requires a compiler version less than 0.80, it is not going to give any error here. However, one would get compile at the error. One would get compile error at some point of time, right? So just be careful whatever the files that you are importing here. Now this import statement here is really a cool thing that Hardhat provides, right? So you see Hardhat console.solidity, so we can basically have a console.log statement in the Solidity file itself, and that is like really cool to have because it becomes easier for you to debug. Okay, so what I will do is I will write down the contract. So my contract is going to be named as counter, right? So my contract will be okay. So I already got just a second. Okay, so here's my contract. What I will be doing is I will be creating a state variable. Now state variable in Solidity is basically something which is permanently stored on the blockchain. So what we'll do is we'll basically have a positive number which is uint, which is by default will be 256, and we'll make that public because it's a very basic contract. So I will basically want everyone to get access to whatever the values we're storing in this contract. So it is going to be public, and we'll name it as a count, right? So this is basically going to be our public state variable that we will basically be incrementing and decrementing into. Now the second thing that we'll do is that while our contract gets created, a special function called constructor will be called, right? So I will basically be having a constructor, and then in that constructor it is again going to take a uint which is going to be positive value, and we'll pass on the count. Now why I'm writing this is basically if you want to set some initial value to counter, you can go ahead and set it. However, even if you don't write this constructor, it is completely fine because in Solidity it will anyway get initialized to by value 0, right? So even if I am passing on say nothing, I'm not passing anything, it will get initialized to 0 itself because there is no concept of null and none in Solidity, right? So what we'll do is whatever the value that we are passing while at the time of compilation, will basically set that in, right? So you can set any value, and then basically that value will get stored into the state variable. Now what we'll do is we'll write down a function. Now the first function will be basically to get the count, right? So get count, right? Now this function is not going to be it's not going to take any params because we just have to write a getter. This function is going to be again a public function. It's going to be a view because we are dealing with a state variable here, and it is eventually going to return us a uint value, right? So this is going to be returns and yes, right? So what it will do is it will simply return say the count, right? Now since we are using hardhat console.log, so what I will do is I will put a console log statement as well, so that while we run our test cases, we get that log as a part of our coverage report itself. So we'll have simply the console.log, and what we'll do is we'll just print the value of it, so which is going to be the value of count, right? Okay, so this is going to be closed in a parenthesis, and here you go, right? So count, right? So am I getting any error? No error. Fine. Now the second function, and which is the function where we will be updating the increment, is going to be very simple, and all of this basically looks like say any other programming language, mostly object oriented programming language. So my function here will be called as increment, right? So it's a very simple function. We are just going to increment, so I do not need to take any params in it, and then this is going to be a public function, right? And then so what we'll do is we'll simply have count is equal to, say, count plus 1, and then we'll have a console.log, and what I will do is say the value after increment. So the value, so what we'll do is we'll simply write it down like the value after increment, right? And then we'll go ahead and print this value. Okay, so that's it about say our contract. It's a very basic contract. If you see, we just have two methods. One is the get count and another one is the increment count. Now